Okay, in this video, I'm going to show you to solve tutorial 9, question 1 and 2. Okay, still remember in chapter 9, we have learned about this formula to integrate powers of sine and cosine. You can make use of this equation and this. For sine is this and cosine is the second one. So in tutorial 9, question 1, part A is to solve integral of sine to the power of 5x dx. So there are two methods. First method is you can apply this formula to solve this. So it becomes negative 1 to the 1 over 5 sine to the power of 4x cos x plus 5 minus 1 4 5. So the integral become out of 3x dx. So you can reapply this formula to solve this integral. So this is method 1. So if you don't want to use this formula, there's another method without using this. Method 2, you can split the integral, becomes sine to the power of 4x sine x dx. Then you make use of the trigonometry identity where sine square x plus cos square x equals to 1. To convert this, sine to the power of 4x become 1 minus cos to the power of 2x square sine x dx. Then you expand this. Before you expand the bracket inside become 2 cos 2x plus cos to the power of 4x dx sine x dx. So now for this, you can use u substitution to solve. So how to use u substitution? You let u equals to cos x. So when you differentiate, it becomes negative sine x dx. So you can replace sine x dx by negative du. So you continue. So this integral become 1 minus 2u squared plus u to the power of 4 negative du. Then you can straight away solve this integral. So question 1 part B. Question 1 part B is to solve integral cos to the power of 5 x dx. So same thing. The first method is you can use this formula to solve this for the first method. Or the second method is you can split it up. You can split it, it become cos 4x cos x dx like the previous question just now. Then you make this become 1 minus sine square x squared. Okay, and then you expand it. So now you can make use of the u substitution to solve the integral. So let u be sine x. So differentiate, you got cos x dx. So you can replace cos x dx by du, and then further simplify. Further simplify, this integral become 2u squared plus u to the power of 4 du. So now you can straight away integrate this formula. Okay, we continue for question 1. Part C is to integrate tangent to the power of 4x dx. So same here. First method, you can use this formula to solve. Or the second method is you can actually split tangent to the power of 4. You can split it, become tangent square x times tangent square x dx. So it becomes tangent square x times secant square x minus 1 dx. So you expand the formula, it becomes tangent square x secant square x dx minus tangent square x dx. So for this one, for this integral, you can use u substitution to solve. So you can let u equals to tangent x. So when you differentiate tangent x, you got secant square x dx. So this, the first term integral, it becomes u squared du. So you can straight away integrate this. For the second one, tangent square x, you can use the formula, this, to solve it. Okay, question number 2, part A, solve this integral. minus 12x to x squared dx. So this one is actually similar to this. You can make use of this special form to solve this integral. Okay, so how are we going to make it into a special form? So first, we have to simplify the quadratic equation at the denominator. So simplify quadratic equation first. So always have a good habit to make the coefficients of the highest power x squared to be 1. So from the integral, we pull out square root 2 first. So it becomes 7 minus 6x minus x squared. Okay, so now we use this integral, this quadratic equations to simplify it to be seen as the special form. So we make it 7 first part, and then this one minus x squared, so make it bracket plus 6x, so be the second part. So we know that if we add half of the coefficient of x, which is 3 squared, so the second part we add, we actually minus 3 cubed. So the first part we also we have to add back 3 squared. So it becomes 16 minus. So now the second part you can straight away factorize it, become this. So 4 minus x plus 3 squared. So the integral become 1 over square root 4 minus x plus 3 to the power square. So now you can straight away integrate it. So make use of the form inverse sine x plus 3 over 4. Okay, let's look at question 2, part B. Is to solve this integral. 3 plus 6x minus x squared dx. So we always have a good habit to check out the coefficients of x to be 1. So here's the coefficient of x is 1. So we can try to make this integral to be same as like this. Okay, so we have to do something with the denominator. Okay, now we simplify denominator. Same thing, we make it to the first part here, second part be x squared minus 6x. So for the second part, in order to straight away factorize it, so we know that we can add half of the cube of it. Half of 6 is 3 square. So the second part we actually minus 3 square. So the first part we also have to plus 3 square back. So we have to add 3 square backs in order not to change the value of it. So it becomes 12 minus x minus 3 square. So this is 2 square root 3 square minus x minus 3 square. So we could actually make it becomes like this. Dx. So make use of the special form, straight away can integrate it, so it becomes 2 times 2 square root 3 ln 2 square root 3 plus x minus 3, 2 square root 3 minus x plus 3 plus c. Okay, for question 2, part C and D, they are actually the same. You just make it into a special form. So that one I will leave it for you. So now you look at question 2, part E. Solve the integral sine square x 1 minus cos x dx. So how to solve this integral? You have to do something. You have to make use of the trigonometry identities, and you have to do something with the denominator. So you see, for the denominator, we can actually multiply both numerator and denominator with this 1 plus cos. So if we multiply the conjugates of the denominator, so now the denominator it becomes 1 minus cos 2x, and numerator become like this. So we know that 1 minus cos, we can actually simplify this, becomes sine square x. Okay, so sine square x 1 plus cos x. So now this becomes sine square x. So we further simplify it, it becomes sine x, sine square x plus cos x dx. So you can eliminated, so the integral now become sine x 1 plus cos x dx. So now you can use substitution to solve it. So we let u be what? So in this case, we could let u be 1 plus cos x. So we differentiate it with that negative sine x dx. So we can actually replace sine x dx by negative du. So now the integral become negative du. So now the integral it become negative du. So this become u half. So you can continue to solve this integral.